So hello everyone and welcome to Excited Nuclear channel. And today we are going to see about sets. These are the same things as in mathematics. I know some of you might not be aware of that. So let me quickly switch my screen and tell you what sets truly are. So this is my screen. I think every screen is visible. Yeah. So let me tell you what set is. So set is a container data type which holds values from different data types or maybe of same one data type. So that is what set in Python are. That means set is a container data type which holds value of different data type as well as the same data type. Also, there are some unique properties to sets. So these properties are as follows. So the first is again that I have told you, heterogeneous. Yes. Next is these are generally mutable. And the next is which is quite you can say most or you can say USP of the sets, and that is it don't allow duplicates in it. That means don't duplicates. And the last is actually unordered and unique. So these are what set really are. That means these are the property of sets. So I believe everything is clear up until now because these are the very you can say basic level of definition. So let me just put USP here, and it is the unique selling point of what do they say sets. Now we are going to see the operations of sets and how to create one. So to create a set, we just simply have to you can say initialize a variable and assign it a value with you can say curly braces. And let's say so if I try to print this s and hit the run button and wait for some time until the code execute actually. So it gives us the same thing. Sorry, but I forgot to put the type statement here. Yeah. Yeah, as you can see, we have got our set. So now this is how you create a set. Now let me just quickly create two sets actually. So second set is going to contain 2, 4, 6, 7, 9. Okay, this is the second set R. In the same way, you can check the data type of the R2. So if I try to run it, as you can see, the other is also a set data type. Now we are going to see what are the operations that can be performed on sets. So the operation one is intersection. The next operation is union. The next operation is difference. And the last is so these are what set are actually. Now I am going to so these are actually the you can say operations that are actually what include in set. Now I'm going to explore every you can say property. So let's start by intersection. So we have created these two sets as above. So we are going to use that in this section only. So if I put something like S dot intersection of R, so what it is going to return us is that it is going to return us the common values between S and R. So this is what it is going to return. So let me print that to see what the output it gives us. So why not before running this, I just let write this output here. So the two is present in both. Then we have 4 and 5. Then we also got 6 and 7. So these are the things that it should return us. So now we are going to see what values it returns actually. So congratulations, that's the same thing our set returns to us. And also there is a notable property that we have to think about is that set set are actually sorted by default. That means whatever value you are going to put it in, that means let's say if I have put it here very scrambled values actually, and it returns as the sorted value. So this is the very cool function you can use while you can say implementing some mathematical operations such as calculating median and all. So this is what intersection returns. So that's the same as the sets that you have learned about in mathematics. So there is no new things and all. So the next thing we are going to execute is the union. So S dot union R. So if we are going to run this, it should return us the all the elements from both sets. Let's say also only unique. That means it is going to return us with. So let me just quickly write it from here. 1 comma 3 comma 4 comma 5 comma 6 comma 7 comma 9 comma 10. So these are the value it is going to return. Now let's see what output we get here. So guys, we are correct again, and we get the same output as we have predicted above. So that is a good thing. Now we are going to see about the difference between the sets. Means if I am going to print the values of s dot difference bar. So what should be the output here? It should return elements of s which are not present in R. That means we are going to get, what we are going to get here is that, so seeing from here below actually, so what we have in the first set that we don't have in it in the next one. So that is actually 1. So the output should be 1 here. If there is something else, we are going to see. Also, I think I forgot about the 3 and that is captured by the output. But yeah, our definition actually is true. That means it is going to return the values that are present in S only, but not in R. So if we are talking about symmetric difference, so we are going to run like something like, let's say this time change the uh, symmetric difference. Yes, change the, you can say, values. So this time we are going to get unique values from both sets. That means the expected output should be like this. So as you know, our difference gave us 1 and 3. That means 1 and 3 are only present in S set, and that is quite good. And the other things that are present in, you can say, R, but not in, you can say, S. So these are 9 and 10. So we should also see 9 comma 10. So if we are wrong, it's gonna prove us. But alas, it fails. So we are partially wrong at this time actually. That means we forgot to again consider the 0 from the, actually I got confused in this case. So maybe that's why. But I hope every operation in the set is clear to one and all. And if you think you need some more deep definition about sets, I'm free to explain that. Also, there is one thing that I must mention, that the sets are actually used in the situation where we have to do some analytical operations, and we can say some mathematical operations, where the matter is where we have to use some sorted data. Also, we have to get some unique values from the data. So these kind of things, when we want to implement, so in that case we use sets. So the sets is very, you can say, very usable data type if you are going to use it for your use case. And about the right, about it is also about the right operation that you are going to use. So let's say if you have a task that you have to find out the unique values between name of one person and the name of second person, so that can be done in using sets too. So let's say if I make two sets of names. So the name 1 is equal to Shubham, and the name 2 is going to be our channel name. So these are the two names that we have created. So name, so we are gonna create two sets actually, S1 and S2. So what we are going to do actually, so what we are going to do is set of name. Now we are gonna hit escape button and just and then perform. So our situation is like we have to find the unique element between the two names. So this can be done using which function? Yeah, that is intersection. What we are going to do is s1 dot intersection s2. So I believe this should give us the case we want. So if we are just going to print it, I hope this gives the common element, and that is u. That is also, you can see easily visible from here, that u is the only common element between the two. So that means what you get to see from here, that means we can also use strings to create an set. So what if I want to print s1 and s2 first? So if I want to print s1 comma s2, see what it is going to return us, and then consider it yourself. So as you can see, Shubham contain 2h, and here we have only one, and it also sorts the name actually based on the elements, you can say. So this is what it gives us. And the next thing is it also sorts the values. So how the sorting happen on strings actually? Strings are actually at the back end is nothing just the numbers. That means you can say there is an odd function which return us the string element. If I print odd of a, what we are going to get is, as you can see, if I give a function ord, which actually gonna give us the encoding, you can say in the way that how a is encoded at the back end of the computer, or in the memory how the a is represented in the numerical format, and that is 97. So that's how we can find that strings are also nothing but just a numbers that are encoded for you can say for this system, as it is a 64-bit system. So in the 64-bit system, the a is encoded by representation of 97. And that's all for today. I hope you learned more about sets and something about strings. And that's all, and we wrap up here, and we meet in the next video.